Welcome back to the show, everybody. We will round out the Farmall H starter and generator rebuild series today. We don't have a whole lot left. Just go through brush plates, seal them up, and we'll be about done. Once we finish with that, then we'll wander over to the very interesting items that are on this bench right here. You'll have to stick around to the end to see those. Trust me, it is going to be worth the wait. So the reason I did not record any of the minor reconditioning and cleaning that I had to do to either of these brush plates is because I knew these really didn't need anything actually done to them, so they wouldn't be good examples. I, however, had this starter that I knew would be excellent for this episode. This is the one off of the 48 McCormick W4 tractor, and if you all did not see the Will It Start episode on that, I just popped the link right here, and if that link does not show up for you, I'll throw another one up at the end of this episode. So in that Will It Start episode, I found that the end plate for this starter is the cheaper aluminum. Actually, I think it's a pot metal version, and it was all cracked and heaved, and that's why this starter did not work. And because a W4 is the same as a Farmall H, and I already had my Farmall H starter off of the H, I just took this one off and put the H starter on so that we could continue on with that episode. So today we will disassemble the brushes from this cracked and junk end plate. We will replace it with a Delco Remy original, nice heavy cast version. Swap all those brushes over to here because they are still good. And then we'll do the circuit checks and make sure everything checks out, and then get this starter sealed up, and we'll have an episode. So let's get busy. Okay, so we got the old cap and the vise. 4-brush starter, pretty standard arrangement, all right. And we have to look at the brushes themselves because they are different. So we've got this brush, and across from it, this brush. They are connected with this wire, all right? And they are also on pegs that are insulated from the cap. You can see a little bit of the insulation sleeve right there. Insulates both the spring stop and the main pivot peg on each side. So these two brushes are insulated from the cap. These two brushes then are grounded directly to the cap. The pegs that they're on are not insulated, and they've got these little jumper wires with terminals that ground directly to the cap. So that's your difference in the brushes, and we need to make sure the correct brushes go back on the correct pegs when we put them on the new cap. Now, typically when you get a new set of brushes, you don't get this whole spring-loaded pivot arm. You just get the brush and the section of wire. And you would just pivot the arm out, take that little, sometimes it's a bolt, sometimes it's a machine screw, but you take that out and then disconnect where the ground lead goes to the cap itself. All right, get that out of there real quick. And then that's how you would replace the brushes. Just the individual brush, you would leave these pivot arms in place. But for what we're gonna do today, we're gonna leave these brushes on the arms and just remove the arms and the springs as a unit. So to remove the whole pivot arm, it's pretty simple. We've got the coil spring in the center here. One leg of the spring is back here, you see that? And that exerts pressure onto the arm and the brush, keeping the brush up against the commutator. The other leg of the spring is hooked behind this peg right here. And we need to get behind that, like with a small pick. Here we are, get that arm off of the peg. At that point, it takes all the tension off of the spring, and since we've already got our ground wire disconnected, the arm and the spring just pull straight up and disengage. That's all you have to do. Old broken plate goes away. Save that though in case you need to turn in a core. Don't give them your really good heavy cast originals. Give them the cheap broken one instead. New replacement heavy cap now. And I neglected to mention before, but I've been using this dowel peg as a 12 o'clock indicator that helps you to get the brushes back. in the right spots. The bushing in the center of this one is very good, so that's a bonus. And now you can easily see which pegs are the insulated ones. You can see the insulating sleeves at the base of these two, and then these two have none. These two have the insulating sleeves. These two have none. So that sets us up for the continuity checks that we should do to this cap before we put any brushes on. So down here at the ohm meter display, watch that. So we should have no continuity from these two pins to the cap. Let's give it a test. Good there. Good there. These two pins, we should have perfect continuity. Yep. And good. These two pegs should be insulated. No continuity. Good. And good. And then we should have good continuity on these two. Non-insulated. Yep. Good. We have a good cap. So the jumpered pair of brushes go back onto the insulated pegs. Start the spring in. Get the leg behind the arm, all right. Get it started onto the peg. Now we might need to take a few attempts at this because I need to manage to hook that bottom leg of the spring like that, and then if the universe is with us, we can get it behind that peg. There we are, hook it. Engage the rest of the arm. That's good. And do it again. Upper leg behind the arm. Start it all on the peg. Hook it with the pick. Get it behind the peg. Start the upper part of the arm. Good. And then all that's left is to tighten the ground wire screws, and we've got a brush plate fully assembled. Looks good. So those steps are the same that I did to these other two units over here. This is basically the same thing, okay? Just a lot of cleaning, verification, make sure the contacts are all good. The generator, this is a third brush style generator. Some of them are only 2, some of them are 3. This is a 3. And it looks a little bit different, but the principles are all the same. This brush and this brush have the insulating pads under them. You can see that black strip right there and the other one right there. So those two had to be insulated from the plate and the cap, whereas this one grounds directly to it. So with all of that verified, we can start putting together. So a couple of things to mention real quick. We've got this thrust washer that goes on the back of the starter armature. We do not have a thrust washer on the generator because everything is controlled by the pulley that fixes the shaft at the front. So that front ball bearing takes all the end play there. We just have a straight bushing in the cap. Now both of these caps have the oil cups on them. All right, spring loaded cap in there. And it's not just a direct shot down to the bearing bore. This one's difficult to see, but there is a piece of wicking felt that goes down through here, and just you can kind of see the notch in the in the cap bore down in there, that's where that felt comes in. So that just meters the oil that you put in there gradually so that it doesn't get one big slug right away and then starts to run dry. You can see it a lot better on the back of the generator cap because we've got that removable plate here. And here's the oil cup. And you can see the piece of felt comes down and around. This is also a little bit of an oil reservoir down here. And then it wraps back up. And there's a slight cutout once again. You can see it in there in the side of the bushing. And then we have just a plug that caps the other hole off right there. So that's a very important piece to have in place. If your wicking felt is bad, you can get it from McMaster-Carr brand new. They've got all types of sizes, grades. Just type in and search for wicking felt and you will find it. So we've got this gasket here, and then this tin cover will go on using those 3 screws. All right, we're ready to throw the cap on. I've got a couple of props with me first. Going back to a common question from the comments section the last time, I mentioned the electrical, let's get it up in frame here, the electrical grease that I put on the mating joints surfaces of the cap and the body and the nose cone. It is this, and I know we've got a sticker that covers most of it, but this is Motorcraft electrical grease spec XG12, okay? Not to be confused with the Motorcraft dielectric grease that I also have, that is the XG3A. The tubes are almost identical, okay? But you can see this one says electrical grease. That's the one that I use. That's the one you want in this application, the XG12. This is made by Nye Lubricants, and it's very, very good stuff. We put it on airbag electrical connector contacts, anything that was exposed to potential water ingression. It provides a perfectly conductive finish that also resists corrosion. So that covers that. Now, this style of brush plate, I've found no good way to hold these spring-loaded brushes back while we put it on, so I just kind of align it, and then you got to go through with a small pick, and one at a time just peel the brushes back and set the cap down around the commutator as you go. The generator is much more straightforward because it's a little bit better design or different designs. So that said, just align our dowel with the hole and work them down one brush at a time. Just like that. I'm just making sure the contact leads are in register with the lugs on the inside so we can align the dowel hole. There we are. So we can secure the cap with the long bolts. Sometimes these can be a bit tricky to start because as you guide them down, the end of them can walk around so much. Starters are generally not too bad because of the 4 field coils. They serve as a pretty good guide to kind of cage the bolt in. Send it down to where it needs to be. And finally, tighten down the brush leads to the lugs that come off of the field coils. All right. Okay, so now we get to do the brush plate for the generator, and this is a different design, but it's actually a lot more user-friendly. So instead of the spring-loaded arms being attached directly to the brushes just float in these tracks, and the arm just presses on them, okay? And on the surface, it would seem like this is going to be a lot harder to keep everything together and line up. And in reality, it's not. I'll show you a little bit of a trick here. So I'll hook that spring-loaded arm, and we'll just overextend it so that we can get the brush just a little bit past it. And then just like that, it will hold the brush well back away from the commutator. Do that to all three of them, and you can just put the cap right on, no problems at all. Just like that. So now we just put the cap on. Isn't that simple? Seat the brush. Seat the brush. And seat the brush. 2 long bolts. You probably know the drill by now. And hooking the 2 inside leads up to the brushes, we need to make sure, we get them put in the right place. All right, so we've got the 2 brushes close to one another on this side. If you flip it over, the solitary one over here is called the main brush grounded in the manual. Okay, so 180 degrees from that one is this one. That is the other main brush that is insulated. That is the one that the A terminal lead here has to hook to. So that means this one is what's known as the 3rd brush. That is the lead that comes from the field coils that hooks to the 3rd brush. So hopefully that makes sense. Or for a better visual, looking right at the back of it, on this side, solitary brush, that is the main brush that is grounded. And then on this side, 180 from that, that is the main brush insulated, so that is A terminal. And then this brush up here, that is the 3rd brush, field coil. So main brush grounded, main brush insulated A terminal, 3rd brush field coil. And coming down to the last few parts, we have the bands that cover the brush windows, okay? And as you can see, we've got some gasket material that is stapled to them. These were the originals from the generator. They were a rather heavy type of gasket material. Kind of some neat old lettering visible there yet. I chose to just make some new staples and replace it with some fresh material. And we've got a similar deal for the starter. This band only had a single staple right down in the center, and it had a longer continuous strip that pretty much had to cover the whole band. All right, so we'll get this placed inside, decide where we are going to center it out. That looks good right there. So we just poke the staple legs through it, fold the legs, and we've got a stapled gasketed band ready for assembly. Just trying to center the gaskets up with the windows. That puts the joint here conveniently on the bottom, because you know it can be kind of tight against the hood, so one less item to stick up, potentially interfere with something. And here we are. We're at the finish line. Just going to throw the hardware for the contact points on where they need to be so they don't get lost. And we're all back together. Generator and starter. I think they turned out pretty well. Interesting thing I just noticed a minute ago, the old pieces of gasket material from beneath that generator band. If you throw them side by side, they must have been cut from the same sheet. Victolex, gasket, and packing. Neat old logos on that stuff. So All right, the only thing left to talk about is the ID tag. You can see I removed the one from the starter, and that's because it had kind of an oddball one on. It's an all steel tag. It's not like the normal aluminum that has the Delco Remy Anderson, Indiana lettering. It didn't have like this space in the center where they would stamp all the numbers. This was just basic steel, no other lettering, and just a very faint, you're not even going to see it on camera, a very faint series of stamps on there. And it was just deteriorating to the point that it was barely legible anymore. So in order to preserve that data, I purchased reproduction tags from Steiner Tractor, and they even come with the new rivets to attach them. But when they show up, they're blank. I had to stamp all of these numbers on there, so I just transcribed what was on the original. Model number 11074448 and serial 82586, and I think it turned out pretty well. When we go to install that, that's going to look really good, especially after the rest of that is painted nice shiny red. But we'll leave that off for now until we can get everything painted, and then we'll go ahead and pop that on. Saves us having to mask it off anyhow. But one difficulty you will encounter when you're trying to replicate the stampings, it's very difficult to find the actual font that any of the manufacturers used on anything. Generators, starters, tractors, what have you, they kind of had their own proprietary font. So the Delco Remy stamps in here, the originals were like 1/8 of an inch tall, but they're really skinny. And the closest I could find was this C.H. Hansen steel stamps kit. Okay, these are 1/8 stamps, but they are a little bit wider than what the originals were. So that means I had to really crowd them close to one another to be able to fit everything on there with an appropriate space in between. But the way I was able to stamp those, these stamps are 1/4 inch square on the body. So I made 2 pieces of steel. Here's a backing. So I would just put the blank tag on that, and then I cut a 1/4 inch slit, and I threw some, scribed some graduation marks in there to try and get my spacing correct. And I would just center that over the blank space to be like a guide, okay? And then that would help me to align the stamps, and I had all the spacing, and it kept everything in a nice straight line, and it turned out pretty well, I think. So a couple handy little, very rudimentary tools, but helped the process considerably. Yeah, I like it. And now finally we get to these interesting units back here. But to segue into that, it has to do with how these ID tags are colored, and based on the color you can usually identify at least what voltage range these run in. So typically all of the 6-volt units here is a black background. That tag. Okay, so generally if it's a black background tag, it's a 6-volt unit even if you can't read any of the stampings anymore. When they switched to 12 volts, they went with a red background tag. Plus a lot of the 12 volt ones say 12 volts, you know. So black is 6 volt, red is 12 volt. Pretty standard, you know, you can take all that for what it is. But have you ever seen a Delco Remy tag that has a green background on it? Like that one there has one, that one has one, that big starter has one. And I'll give you a hint. These are all from prototype Minneapolis Malines, okay? The first time I ever found a Delco Remy tag that had a green background on it was when I was restoring the prototype crawler X253, and the Delco Remy generator featured right there. To this day, it still has that green tag on it. Now, what's the significance of a green tag on a Delco Remy product? You can see it right at the bottom here. They have engineering sample written on them. All 3 of these are the same. And that is an anomaly, because if you look at the black tags, it just says automotive electrical equipment on the bottom. The red tags usually have made in USA. But engineering sample on a Delco Remy means that that is a prototype in and of itself. So these are basically Delco Remy prototypes. And these all came from that Jones farm that had all of the Moline prototypes on it back in the day, where ours came from. They're all really oddball things. We even got like 4 or 5 of these big ones, and they're all the same. They've got that same green tag. All of these have just the regular contact switch engagement. This one's missing the housing. You can see the heavy copper contact right there. This one even has a little pivot arm that comes in from a remote linkage. Very interesting stuff. This starter right here, if it looks familiar at all, it's because it's the one off of X231, the prototype tractor. You can see that's the same starter right there in that picture. So Minneapolis Moline relied heavily upon prototype Delco Remy electrical equipment, but part of it too was, I think that's how they got starters to fit their specs, because having a 3-bolt flange on a Minneapolis Moline is very rare, but this whole nose cone is just oddly shaped. The starter drive in here is very atypical, okay? This starter, I have no idea what it was off of. It's got the Prairie Gold paint on it. I'm sure it was off of another prototype Minneapolis Moline, but the 3-bolt flange on this one is a lot bigger than what's on X231. So one can only speculate what this one was originally from. It has a little bit more standard shaped nose cone, but still a very big starter drive gear for the size of the rest of it. Just very, very interesting stuff. So another thing too, none of the numbers on any of these units are in any of our Delco books. You've seen our Delco books. They're like that thick. Okay, we've got pretty much everything that you should be able to have. So I've written the serial numbers and model numbers down because we'll never read them on camera. But the X231 starter, it is a model number of X11199. That's weird having that X in there. Serial number on that is a 342XF. So X is usually definitely prototype. This one right here, I don't know what it's from, but that is a X11986 model, 569 SA serial. And this this big guy back here, that's got a X10478 with a 129ZC serial number. So prototype Delco Remy stuff on prototype Minneapolis Molines. And luckily we were able to snag a lot of that stuff from that old farm before it got scrapped too. So figured I'd show you all that. It's kind of an interesting deal. So that's going to round out the starter and generator rebuild series. I think I covered about everything I wanted to, and even threw a little bit of extra story time in. Thought I was going to get through it in one take. So thank you for watching, everyone. If you stuck it out with me for this long, congratulations, you did very well. I'll pop some links up for that W4 Will It Start episode, and I think I can squeeze in a link for the kind of the backstory on that Jones Minneapolis Moline farm back in the day that had all the prototype tractors, in case you all are new to the channel and you weren't around when we did all that. So I thank you for watching, everyone, and I hope to see you all back again.